BIM Digital Fabrication and Disaster Planning by Peyton Maloney. What is building information modeling? Across the world, BIM, or Building Information Modeling, is becoming a crucial and even mandated process to ensure the planning, design, and construction of buildings is highly efficient and collaborative. Two different definitions will be presented. The first, Building Information Modeling, or BIM, is an intelligent 3D model-based process that gives architecture, engineering, and construction, or AEC, professionals the insight and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. And this definition was given by Autodesk. So the second definition of Building Information Modeling, BIM is a highly collaborative process that allows multiple stakeholders and AEC, or architecture, engineering, construction professionals, to collaborate on the planning, design, and construction of a building within one 3D model. It can also span into the operation and management of buildings using data that owners have access to. This data allows owners and stakeholders to make decisions based on pertinent information derived from the model, even after the model is constructed. And this definition was given by constructibletremble.com. Digital Fabrication Example 1. The first description is as follows. A process that uses digitized information to facilitate the fabrication of construction materials or assemblies. Some uses of digital fabrication can be seen in sheet metal fabrication, structural steel fabrication, pipe cutting, prototyping for design intent reviews, etc. It assists in ensuring that the downstream phase of manufacturing has minimum ambiguities and enough information to facilitate with minimal waste. An information model could also be used in suitable technologies to assemble the fabricated parts into the final assembly. So what is the potential value of digital fabrication? Digital fabrication ensures quality of information, it minimizes tolerance through machine fabrication, it increases fabrication of productivity and safety, it reduces lead time. Digital fabrication can adapt late changes in design, and it can also reduce dependency on 2D paper drawings. So the team components and what is required of that, the ability to understand and create fabrication models, ability to manipulate, navigate, and review a 3D model, ability to extract digital information for fabrication from 3D models, ability to manufacture building components using digital information, and ability to understand typical fabrication methods. Digital Fabrication Example 2. Digital fabrication is an innovative methodology that blends the benefits BIM with virtual design and construction. Using BIM-based digital fabrication techniques, designers, contractors, builders, and engineers can improve the efficiency of design, construction, and manufacturing of prefabricated products. BIM allows visualization of fabrication designs digitally. Benefits of BIM-based digital fabrication: inclusive integration for greater transparency. BIM-based practices promote the integration of design, manufacturing, and construction processes. This enables higher transparency, better collaboration opportunities, and interoperability among stakeholders in digital fabrication processes. Simplified procurement process. BIM-based digital fabrication reduces the workload of the procurement teams for construction and improves productivity at the same time, as the BIM-based digital fabrication empowers designers, builders, and manufacturers to understand the requirements in a better way. The procurement process gets simplified and more efficient. Improves productivity of workflow. Digitalized BIM-based models in fabrication domain enhance work quality, fabrication, collaboration, and overall productivity. As everything is prefabricated first digitally, there is an optimal utilization of resources and talent, which boosts work efficiently. Digital fabrication for the use of steel fabrication. To understand how BIM digital fabrication can be used to automate structural steel fabrication, it is important to understand how the structural steel components that make up buildings frames are created. First, a steel mill uses a hot rolling manufacturing process to create stock structural steel members. This stock material is purchased by steel fabricators who cut and prepare the stock structural beams and columns for building construction based on shop drawings. These shop drawings are generally created in Revit. Once fabricated, the steel members are shipped into the building site and put in place by steel erectors. The shop drawings that are so important come from the structural engineer. It is their role to design, analyze, and certify a building structural frame, and then create construction drawings that document structural design. A steel detailer then takes those construction drawings, create shop drawings that instruct the steel fabricator exactly how to fabricate each piece of steel in the building. How does BIM fit into all this? Just as CAD-based models in manufacturing can feed the manufacturing process, a purpose-built building information model such as Revit structure can feed the structural fabrication process. All geometry regarding the structural steel is already in the Revit structure design model. This design information can be exported and then reused for future steel fabrication. Another advantage of using BIM in the structural supply chain has to do with the overall cost of the frame. In the past, cost has in general been equally distributed between raw materials, fabrication, and erection. But in recent years, the proportionate cost of fabricated steel and steel erection is rising, a trend that could possibly halt by considering simplicity of fabrication during the design process. An important ingredient to a digital design to fabrication process is some of collaboration between the structural engineer, a steel detailer, and the steel fabricator. In most cases, those three parties represent three different companies. The link between design and fabrication is therefore facilitated by alternate project delivery approaches, where cross-functional project teams representing owners, builders, engineers, and contractors collaborate through all phases of design, fabrication, and construction. Disaster planning and management, a process in which emergency responders access critical building information in the form of a model and information system to plan for and manage extreme events. The building information modeling provides critical information to the responders to improve the efficiency of responders and minimize safety risks. The real-time building from a building automation system, or BAS, along with the static building information such as floor plans and equipment schematics, can be valuable information in the model. These systems can integrate via a wireless connection, and emergency responders can link to an overall system. The BIM coupled with BAS can display location information regarding emergencies, possible routes to the area, and any other harmful locations within the building. Disaster planning and management. Potential value. Provide police, fire, public safety officials, and first responders access to critical building information in real time. Improve the effectiveness of emergency response. Minimize risk to responders. Resources that are required. Design review software to view record model and components. Building automation system, or BAS, linked to data. Computerized maintenance management systems, or CMMS, linked to data model. And some of the team requirements: ability to manipulate, navigate, and review BIM model for facility updates, ability to understand dynamic building information through BAS, and ability to make appropriate decisions during emergency. Disaster planning and management. From tornadoes to floods, earthquakes to volcanoes, natural disasters are unavoidable and supremely disruptive. And in the past decade, we have caused billions of dollars in damage and affected an estimated 3 billion people. Architecture design, however, is evolving to respond more resiliently to natural disasters, proving that even if they are too difficult, if not impossible to avoid, the amount of damage they cause can be prevented. Cheap materials and flawed design methods have more far-reaching consequences than just the wallet of a contractor. Limited foresight affects the community's ability to evacuate properly, potentially costing their homes, their possessions, or their lives. The amount of recovery time it takes to repair buildings is also a key factor in disaster preparedness. A well-built, structurally sound building will take less time, labor, and resources to rebuild than one which is poor quality. It also offers better consumer protection and provides a safer point for the community to rely upon. A building without a good design is simply unsustainable, especially when faced with a natural disaster. Emergency response in a natural disaster relies upon timely, clear communication in order to best address and control the situation, as well as ensure rapid and effective recovery. BIM can help disaster management because of its geometric and topological features which allow for a constant flow of information. For instance, in the event of flooding, BIM can provide current reports on electrical wiring or which walls need replacing to ensure stability, ensuring that emergency responders have accurate and reliable information. By incorporating methods such as integrated design, for instance, engineering and architectural features can be joined to create a smarter structure with better ductility and ecological footprint. BIM helps plan and build with sustainability in mind, and practicing better resource use as well as planning around climate and place allows for less strain on the environment, which can lessen the impact and frequency of a natural disaster. Here are the resources that I used for digital fabrication and use the As You Learn site as well. And here are the disaster planning and management resources that I found. Thank you so much. Have a great day.